Good day, everyone. My name is Muhammed Suleiman MSK. Today we take mathematics. As we know, mathematics is father of all sciences. And the first topic we would like to start with is indices. As you all know, indices are power expressions. Indices is the plural, while index is the singular. In indices, we deal with what we call the base and the power. For example, here we have two letters, A and X. A stands as the base. X stands as the power or exponent or index. And the index or the power or the exponent determine the multiples of the base. For example, 2 raised to the power of 3 simply means we should multiply the base up to 3 times. That is 2 times 2 times 2. So that is the idea of the base and the power. So there are laws that guide all areas of indices with which you can be able to handle your problems with ease. Mainly in indices, we always ask to either simplify, express, or evaluate. So how possible can we be able to understand all the laws of indices? So with the laws, you can be able to handle your problems with ease. So now, let's take a look at the laws of indices. The laws are as follows. The first law says, if you have a raised to the power of x times a raised to the power of y divided by a raised to the power of z. This will be the same thing as, the first thing we consider is the base. They are all the same, a, but the exponent varies, x, y, and z. Then the operators, here we have times, and here we have division sign. So in this case, we only consider one of the bases, a raised to the power of, if you have a multiplication sign between two similar bases, we add the powers, x plus y. If you have division sign between two similar bases, you subtract the powers. So in this case, the 3 bases have now reduced to a single base, but the powers have been condensed to x plus y minus z. Another important law of indices says, number 2, a raised to the power of 0. The base is a, the power or the exponent is 0. This is the same thing as what? 1. Anything raised to the power of 0 in indices, the result is always 1. So with these 2 laws of indices, though the first law seems to be a combination of 2 times and division sign, but we can still consider it as a single law. With this, we can be able to handle as many problems as possible. But there are other laws of indices. For example, number 3 says a raised to the power of minus 1. In this case, we have a negative index. This is the same thing as 1 over a. By taking a reciprocal, we've eliminated the negative sign. Then, another important law of indices, let's call it number 4. Number 4 says a raised to the power of minus, for example, n. In this case, this is negative 1, while this is negative n. So they may look similar, but this will be the same thing as 1 over a or raised to the power of what? N. Another important law of indices that may be similar to this is number 5, a raised to the power of minus 1 over 2. Have fraction of power. Fraction of power. Well, first of all, let's consider the positive index. a raised to power of 1 over 2, this is the same thing as the square root of a. Then the situation where we have maybe a as the base raised to power of minus 1 over 2, this will be the same thing as 1 over the square root of a. Then, by taking the reciprocal, we've eliminated the negative sign. Then, once the index or the power of the exponent is half, is much similar to the square root of that particular base. So, another important one, we may have a fractional base. For example, a over b all raised to power of minus 1 over 2, for example. This would be the same thing as, to eliminate this negative power, we now take the reciprocal of the base. This would be the same thing as b over a all raised to power of a half. At the same time, while considering log 5, log 6, this would be much correctly to express as the square root of b over a. So in summary, if you should consider root 7, in summary, root 7 can be denoted this way. If you have a over b all raised to power of minus, let's say, x over y. So this would be the same thing as removing the negative index, can take the reciprocal of the base, b over a all raised to power of x over y. Then to respect the fractional index, this would be the same thing as the y roots of b over a all raised to power of x. So with this, then we can be able now to solve as many, or to simplify or evaluate as many indicial expressions as possible. Examples. Suppose we are asked to simplify the following. Look at the first one. Simplify the following, more especially white, NECO, JAM, and post-UME students. 27 raised to the power of n times 3 raised to the power of 2n divided by 9 raised to the power of 3n. The first thing expected of you as a student, you identify. First of all, this is indicial expression. The bases are 27, 3, and 9. The powers are n, 2n, 3n, while the operators are times and division sign. So the next thing you think of is, what is the smallest base? The smallest base here is 3. So what are the possibilities of expressing 27 and 9 in base 3? For 27, this is something like 3 by 3 by 3, which is 3 raised to the power of 3. For 9, something as 3 times 3, which is something like 3 raised to the power of 2. So in this case, to express 27 and 9 all in the least base, so we can handle this as, let's say solution comes here, 27 raised to the power of n times 3 raised to the power of 2n divided by 9 raised to the power of 3n. This will be the same thing as 3 raised to the power of 3n, 3 raised to the power of 3 for 27 times n times 3 raised to the power of 2n divided by 3 raised to the power of 2 for 9 multiplied by 3n as the initial exponents. Now, all the bases are the same. Considering law 1 that says a raised to the power of x times a raised to the power of y divided by a raised to the power of z. So this would be the same thing as 3 raised to the power of 3n plus 2n, that's a positive sign here, minus 2 times 3, 6n. So now we can be able to simplify the exponents. So this will now be the same thing as 3 raised to the power of 3n plus 2n, 5n, then minus 6n. Supposing it's 6n minus 5n, would have said the result is n. But now this is 5n minus 6n. Then the result will be a negative result because we are subtracting a large value from a smaller one. So this will be 3 raised to the power of minus what? Minus n. Considering one of the laws of indices that says a raised to the power of minus n. To do away with this negative index, we now take the reciprocal. So this would be the same thing as 1 over 3 raised to the power of n. Hence, the simplification of this, always to simplify means to evaluate, to reduce in size. So 27 raised to the power of n times 3 raised to the power of 2n divided by 9 raised to the power of 3n has been reduced to 1 over 3 raised to the power of n. Another example. Example 2. 1 over 3 raised to the power of 5n times 9 raised to the power of n minus 1 times 27 raised to the power of n plus 1. N plus 1. In this case, we have a fractional index. This is almost similar to example 1, but the only problem here is that the initial is given in fractional form. So the first mark will be given to a student that can be able to express 1 over 3 raised to the power of 2n as negative index. So the solution comes here this way. 1 over 3 raised to the power of 5n times 9 raised to the power of n minus 1 times 27 raised to the power of n plus 1. So 1 over a in indices. 1 over a is something as 1 over a is something as a raised to the power minus 1. So this would be the same thing as 3 raised to the power of minus 5n times 9 raised to the power of n minus 1 times 27 raised to the power of n plus 1. So the next thing expected of you is you identify what's the smallest base and see the possibility of expressing other bases to the smallest base. The smallest base here is 3. So in this case, let's express 9 and 27 by 3. So to be honest, this would be something like 3 raised to the power of 2 into minus 5n, the initial index, times 3, alright, 3 here is already the least base, 3 raised to the power of 2 into n minus 1, then times 3 raised to the power of 3 into n plus 1. Now that the bases are all the same, considering the first law, so we now take 3 raised to the power of minus 5n plus 2 into n minus 1, then plus 3 into n plus 1. So we now simplify. By simplification, this would be the same thing as 3 raised to the power of minus 5n. Then we multiply plus times plus is plus, 2 times n is 2n. Then again, plus times minus is minus, 2 times 1 is 2, then plus times plus is plus, 3 times n is 3n, plus times plus is plus, then 3 times 1, 3. So the next thing is just the simplification of the exponents. How can we be able to simplify the exponents? It will be the same thing as 3 raised to the power of, look at minus 5n, 2n plus 3n plus 5n. Then 3, instead of saying minus 2 plus 3, because we simplify like terms, The like terms here are minus 5n plus 2n plus 3n, while another like terms that do not contain variable, minus 2 and plus 3. So 3 being positive minus 2 give you 1. So now we have minus 5n plus 5n, which is still the same thing as saying 5n minus 5n, which is 0. So at the end of the day, you can easily say minus 5n cancel plus 5n, so the result is 3 raised to the power of 1, and whatever base raised to the power of 1 is much similar to the base. So in this case, the answer is 3. So now let's take the last example on indices. Welcome back, students. So we're going to take 2 more examples, such a way that you can be able to simplify all problems of indices, being it in WAEC, NICO, JAM, post-JAM, SAT exams. We are still simplifying. Let's take a look at this example. We also simplify, call it example 3. 3 raised to the power of 2n plus 1 minus 4 into 2 raised to the power of n minus 1, all divided by 2 raised to the power of n plus 1 minus 2 raised to the power of n. So surprisingly, in this case, there is no times, there is no division sign, but imaginarily we have multiplication sign in between 3 and this index, likewise between 4 and the next index, and we have a division sign separating the numerator from the denominator. So one will be wondering how to start this. So as I said earlier before now, one of the most important things in mathematics is identification. First of all, identify this. What is this? This is indicial expression. So how possible can we be able to handle this? Remember all the laws of indices. So this is in accordance with law 1 and law 2. So in this case, let's take a look at this simplification. 3 raised to the power of plus 1 minus 4 into 2 raised to the power of n minus 1, all divided by 2 raised to the power of n plus 1 minus 2 raised to the power of n. Looking at the index 2 raised to the power of n plus 1, this is the same thing as 3 times 2 raised to the power of n times 2 minus, that is solving from the last section to the beginning, 4 times 2 raised to the power of n divided by 2, all divided by, this is now similar to 2 raised to the power of n times 2 minus 2 raised to the power of n, if you should break it to the lowest term. So now, we now multiply the numerals and simplify the index. Numerals are 3 and 2. 3 times 2 is something like 6 times 2 raised to the power of n minus 4 divided by 2 is something as 2 times 2 raised to the power of n, all divided by, this case, this 2 raised to the power of n times 2 minus 2 raised to the power of n. We can easily say that 2 raised to the power of n here is common, so this will be the same thing as just like 2 of this minus 1 of this. You'll be left with only 2 raised to the power of n. which is still the same thing as factorizing. 2 raised to the power of n, here you have 2, then minus 1. 2 minus 1 will be left with 1, 1 of 2 raised to the power of n. So we can also simplify this as, this is 6 of 2 raised to the power of n, while this is just 2 of 2 raised to the power of n. I can easily say 6 minus 2 give me 4. Have 4 times 2 raised to the power of n over 2 raised to the power of n, which is the denominator. So sensibly, we say 2 raised to the power of n, cancel 2 raised to the power of n, left with only what? 4. Another way, or one will be wondering, why so? Maybe from 2 raised to the power of, or 6 times 2 raised to the power of n minus 2 times 2 raised to the power of n, all divided by 2 raised to the power of n. And make a substitution. Say let's, for example, x equals to 2 raised to the power of n. Here is something as 6 times x minus 2 times x, all divided by x. 6 times x will give you 6x. 2 times x, 2x, all divided by x. Then 6x minus 2x, the result is 4x over x. By the time x cancels x, will be left with what? 4. So this is the simplest way you can be able to understand this. Thank you for listening.